should be this one. Should be ready to go. Okay. All right. So no major announcements. If you need to talk, we can do like a breakout session. Like once we at least do the lecture, I want to do about 8 slides. It's not very long. It shouldn't take us too long to get through the lecture, and then we can use the rest of the time. You can either um I mean, I don't mind if you go ahead and get started on your homework. Even if you wanted to go back and improve an exam, if you wanted to ask questions from the exam, if you wanted to, anything that's math related, that's even if it's your what is it called? The Alex. All right. And the way I calculated everyone's midterm grade, if I saw where you did Alex on any level, I pretty much gave you credit. I kind of scaled it a little bit, but Alex is gonna I scale Alex to be 10% of our overall grade. And then 90%, I just took whatever grade I saw on Pearson, and that was your grade for the midterm. The midterm is nothing, it's really just a snapshot of where you are at that time. The one that matters, obviously, is the final grade because the midterm grade can fluctuate. I've had people that be at an F at the midterm and they finish with an A, and vice versa. Okay, so we'll see what it looks like with this online and the COVID climate and everything. But yeah, again, the midterm just serves as just like a snapshot of where we are at that moment in time. Okay. So hopefully you can take advantage of it, use it to kind of adjust something. If you're not getting results that you like, you got to do something different. Doing the same thing over and over and expecting a different result is the definition of insanity. To have something you never had before, you must do something you never done before, right? So that's the idea behind those things. So let's go ahead and let me see. I do intend to let me stream, so I need to share. Mm-hmm. Let's go ahead and share. I think this one will work today. Okay. We don't need this. And I usually like to have the chat showing. Awesome sauce. So yeah, feel free to use the chat or unmute yourself if you have a question or if anything is not clear. Okay, so with that being said, let's go ahead. Again, we don't have a lot that we have to do today. I want to get to at least slide 8. Once we hit slide 8, we'll just pick a good place to stop and we'll stop the lecture for today. Okay. Oh, yeah, I forgot. I usually have to do like this for it to work properly. Hope everyone had a good weekend. We don't get Columbus Day off. You know, I we're at a HBCU, so I totally resonate with the whole thing of not honoring Columbus Day, but to each his own. Another school I'm teaching at, they did take the day off, so I was off on on that campus, but not this one. I don't know. There's a whole everything with me is always some kind of either conspiracy or it's always something controversial. Whether I make it known or not, most of the time it's something controversial. And I just try to keep it to myself. Anyway, okay. So let's see. We are moving into chapter 2, polynomials and rational functions. Again, if you have a question, feel free to type it in the chat or unmute yourself. So quadratic functions. So some objectives here. We're gonna see how to graph a quadratic function in standard form, graph any quadratic function, and solve problems modeled by quadratic functions. Solving problems by quadratics is fun. This is all fun to me. Like once I figured it out, it's actually really powerful stuff. It's fun stuff. But anyway, let me see. Yeah, it's not going to take us long. A function of this form where a, b, and c are real numbers where a is not equal to 0 is called a quadratic function, right? So the leading term is not 0. We have ax. The leading coefficient is not 0. We have ax squared plus bx plus c plus c. This is what we call a quadratic function. Notice the highest degree is 2. The general shape of a quadratic is going to be a U-shaped graph. Okay. Let's see what else we got. Let's see what's next. So the standard form of a quadratic function, say we have this. Let's go like this. We have this f of x equals a times x minus h squared plus k, again, where that leading coefficient is not 0. This is called a quadratic function in standard form, right? The graph of f, let's see, what do we have? Totally breaking my rhythm. Okay. Give me a moment. I need to do like this. I think it does it. That looks right. Over here. Uh-oh. Come on. Oh, looks like somebody might be early. Let me come back. I'll go to users. Yeah. I'm gonna have you come back to the next class. Don't worry about it. That's better. Okay, ain't gonna worry about that. So I think he's just early for the next class. I don't really want to lock it out just yet. So let's go here. And let's put this back. And let's hop back over here. Oh. Okay. Come on. All right. Let me see. View. All right. Okay, so we said this quadratic is a quadratic. This quadratic function is in standard form. The graph of f is going to be a parabola where the vertex is going to be h comma k. So when we start working examples, notice it says minus h. We have to flip the sign of that one, right? So this is the form a times x minus h squared plus k. But the vertex, which is going to be like either the bottom of the valley or the peak of the mountain of the parabola, is going to be h comma k. Okay. The parabola is symmetric with respect to the line x equals h. So we can use the axis of symmetry to create the graph of a parabola. Once you know the vertex, and you can get like 1 or 2 points on either side. Whenever you get a point on the left, you automatically get a point on the right when it comes to parabolas. So you can use that symmetry to easily create a clean graph of a parabola. Okay, if the leading coefficient is positive, the parabola opens upward. If the leading coefficient is negative, the parabola opens downward. Okay. All right, let's see what we got next. So with this example, we're asked to, it says find the standard form of the quadratic function whose graph has this vertex and passes through this point. Let me see, let me give myself some space. I feel like I'm gonna need some space. So I usually like to do the following. Give me a moment, let's add a page. We can get rid of that. We wanna pull this. So I found myself while like just kind of taking a day off. First of all, I went on and voted, thank goodness. So that's done, said it done. It's yeah, that was fun. And then so with my time today, I was kind of relaxing. I decided to watch some like nostalgia movie. I watched Hocus Pocus, and it was like kind of eerie, but it had that kind of nostalgic feel. It was fun. It's just a fun old Disney movie, Hocus Pocus. It's just fun, just for the season, for the holidays or whatever. Just trying to be fun and light. Okay. And once you get past all the subliminal messages of Disney, you know. Anyway, okay. So let's look at this one. Chat. Awesome sauce. And let's come on. All right. Sorry. Okay, I think we're ready to rock and roll. Okay, so we're asked to find the standard form of the quadratic. So that formula that we had on the previous slide, if you have a formula sheet, it wouldn't hurt to add that to your formula sheet. Not that you got to commit that formula to memory or anything, but it is nice to have it on hand, right? So again, one of my mentors would say every time you use a formula, write it down. So let's go ahead and write it down. So if we want the standard form of a quadratic, that's going to be f of x equals a times x minus h squared plus k. Right? That's the standard form of a quadratic. Find the standard form of a quadratic function whose graph has this vertex. So that means our h comma k is going to be negative 3 comma 4. Okay. And passes through the point. So it also passes through the point. We can say that's our x and our y is negative 4 comma 7. Right. So it looks like there might be, let's plug in what we have and see what we need to solve for, right? So if our y is 7, let's do it this way. Okay. So we don't, nothing tells us what a is, so I'm just going to bring a down. Now x in this case is going to be negative 4 minus our h, which is negative 3 squared. Our k is 4, and our y is 7. So notice once we plug everything in based on what they gave us, the only thing that we don't know is A, right? So we can solve for A, right? So let's keep going. Let's crunch these numbers. I'm glad I gave myself some space so I don't feel crammed. All right. So this is order of operations, right? Let's just do a quick recap on order of operations, right? So order of operations, okay, hopefully you've said the little phrase in your mind. Please excuse my dear Aunt Sally's last request, right? Most people do PEMDAS, but they don't include the LR. LR stands for, well, we'll talk about that momentarily, right? So if just to make sure, this is just a brief recap because I feel like it's appropriate. The P in PEMDAS LR stands for, first we target parentheses, right? Parentheses get priority. Once we settle the parentheses, the next thing of priority are exponents. Um, so let's do this. Let's do this color, right? So riddle me this. Which comes first, multiplication and division? Feel free to either unmute yourself or type it in the chat if you want to respond, or just think about it for a moment. Which comes first, multiplication or division? Okay, just take a moment, right? So the M stands for multiplication, and the D stands, or is there another narrative? Does somebody want to chime in on that? Okay, that I think you picked up that it is kind of a bait question. You might be tempted to say that multiplication always comes first, but that's not necessarily the case. The way we do it, we're going to group multiplication and division. So whenever we have to decide, whenever we have to decide between multiplication and division, that's where the LR comes from. LR stands for left to right, right? So there are times when we divide before we multiply. So the multiplication and division, whenever we're on the same level and we have to decide between multiplication and division, we just do left to right. I have seen cases where we're supposed to divide first and it has changed. It has thrown things off. I can't think of one offhand, and I feel like it shouldn't matter, but I think it does. The thing that typically works, if you group multiplication and division, whenever you have to decide between multiplication and division, just go left to right. I've that's been serving me for years. I don't know how that got read, so we're gonna. Oh, back on it. I see what's going on. Let's redo, and I think that's fine. So then next, same thing with addition and subtraction, right? Addition, so this is addition, this is subtraction. We just group addition and subtraction, and we just do those left to right. Let's go like this. Addition and subtraction gets grouped. So whenever we have to decide between addition and subtraction, we go left to right. And again, this LR stands for from left. We do everything from the left to the right. So this is the system that has been serving me for America. Now I think other places might do the order a little bit different but for our purposes, this is how we're going to do it. So with that being said, so when we look at this thing and we go to kind of start simplifying, this says to target the parentheses first, right? Now, if you look at this, obviously nothing inside this innermost nested set of parentheses, nothing to simplify there. So then we kind of work our way out, right? Just like in life, we idealistically want to transform ourselves from the inside to the out. If we're always just like putting makeup on or cutting our hair, like doing things on the outside, and the inside is garbage, then we're gonna feel miserable. You can have everything, money, resources, popularity, fame, but if you don't like who you are, you're gonna be miserable. Versus if you target the inside first, you learn how to be happy. You learn how to, those intangible things that you can't put a price tag on. You master those concepts first. Then it doesn't matter whether you have things or not. You're actually going to be happy. And to me, that's the philosophy I invoke. And I mean, I feel like it works. I don't really have much, but I don't be stressing like everybody else do. Like I know folks that they have stuff, but they don't be happy, man. They be like ready to die. I'm like, man, you need to like abandon that stuff. Anyway, so I brought all that up just again, working our way from the inside to the out, right? So we have this double negative right there, right? So that becomes a plus. Let me just write it out just to be thorough. So the A comes down. Double negative becomes positive. So we have a -4 plus 3, whatever that answer is, squared. I'm just bringing everything else down. right? Some of my students would do this maneuver where they draw a vertical bar to line up their equal signs. I thought it was nice. Again, a lot of our experience in math is influenced by our level of organization and neatness, right? The more organized we can be, the easier it is to follow. If we're sloppy and not writing everything down, we're not detailed. When we go back to read it in the future, we're gonna be like, wait, what was going on here? We're gonna be totally lost, right? So neatness and organization totally helps here. So then -4 plus 3 is what? -1. I'm just gonna keep writing everything. So that answer was -1. Everything else stays the same. I'm just bringing everything else down. Okay. -1 squared is a +1. So then if we go ahead and write the next part, that's going to be a plus 4 equals 7. Subtract 4 on both sides, a equals 3. Okay. Feel free to type in the chat if anything is not clear, or stop me if we need to go back, right? So we solved for a. Let's go back and answer the question being asked. It says find the standard form of a quadratic whose graph has this vertex and passes through this point. So the main items that we need are a, h, and k. All right, so we just found a. So we have that a is 3, and I think we were given h and k was the 3, -3, 4. So let's put this all together. Let's copy, paste. So if we put this all together, again, let's start with the standard form. F of x equals a times x minus h squared plus k. Okay, I'm watching the clock. So if we plug in the items that we just found, our f of x, our a was what, 3? X, we want an equation, so we leave the x. Now our h is -3. Notice how I did a blank set of parentheses to do my substitution for h. If I didn't do the blank parentheses, it's very easy to miss that negative, and it'll mess us up, right? And then our k is a +4, right? So then one more thing, because we have that double negative, we get f of x equals 3 times, what is that, x plus 3 squared plus 4. Okay, this looks good. Okay, I want to show you guys something. So if you have like a graphing calculator, now, I mean, honestly, since this is a remote class, you can, I'm going to show you how to do some things on a graphing calculator, but you can honestly use, there are a lot of free softwares for like graphing things on the computer, right? One of them is called GeoGebra. So I would just do a web search for, let's do this color. Like GeoGebra is a, I'll just put .com so you know it's a website. But it's good for just graphing, like just visualizing graphs, right? So GeoGebra is a good one. There are others. I know there were some that students use, but this is the main one I use if I'm not going to use my calculator. I discovered this virtual calculator. Let me pull it up. Some years ago, some students, it says from Chemtech or something like that, they made this virtual calculator. It's ROM, this emulator. It takes a little bit of effort to get it to work, but once you get it working, it works really nice. So some students developed it, and I've been using it for years. It took me some years to find it, and I never thought to just make it, but I think that would be a worthy experience to figure out, can you make ROMs and emulators? Because if you can figure it out, then you'll be primed for like actual work, like actual like software development. So like if you can, like, you wanted to make an emulator, like take your favorite gaming station, like even something simple, just start creating, and then when you can do things that other people can't do, then you essentially can write your own ticket, right? So anyway, so here I wanted to show you the following. So I'm just showing you how I would check something like this, and just showing you some of the capabilities. So it says find the standard form of the quadratic that has that vertex and passes through that point, right? So let's look at this. First, I want to plot these points, right? So I'm gonna go here to stat. I'm gonna click on stat, and then I'm gonna go to edit, and I want to type in these ordered pairs. So we have -3 and -4, and then the y values are 4 and 7, right? And then I'm gonna go to stat plot in the upper left hand corner here where it says stat plot. I'm gonna click there, so I'm gonna hit second y equals, and I want to turn my stat plot on, and I think everything else is fine. So if I hit graph, those are the 2 points. One of is the vertex, and the other is just a point that it passes through. So now to see, thank you. So now to see how do we do with our calculation, we can get a sense of if it works or not, right? So now I'm going to go to y equals, and I want to type in that formula that we just found. This is just me checking um, before looking at the answer, right? If I wanted to, like, if this were a testing environment, how could I check to see if this works? And I'm kind of intentionally taking my time because we got a lot of extra time, so it's okay. Let's type in this formula that we found: 3 times x plus 3 squared plus 4, right? I just typed what we found. So now if I go back to the graph, this graph should have the vertex. The vertex should occur at -3, 4, and it should pass through the second point. So now I'm going to hit graph, and there you go. It passed. There was the vertex, -3, 4, and it passed through that point. Yeah, so this looks good. I'm going to go ahead and look at the answer now. And again, this whole experience is not really about the answer. Give me a moment. It's about how do we get there? What's the logic? What's the reasoning? That's what a lot of this experience is. This is a side note. I had to learn though, in actual like application of like life stuff. I used to like live my life by this notion of why are you doing? Why are people behaving the way that they are? And I realized that for life, that don't really fly. It's powerful. I think it's powerful when helping others, but when it comes to like helping yourself, you just instead of saying why is something, why this or why that, say what, like what is it that I want. But I'm still developing that notion, but I used to just live by this thing of knowing the reason why, and a lot of times there was no reason. Sometimes a lot of times people were just doing stuff to be facetious. Find the standard form of a quadratic. It has this vertex passes through that point. Let y equal this be the quadratic function. They started with the general form, right? Same place we started. The standard form of a quadratic here. They plugged in the h and the k. Notice the use of parentheses. I feel like I'm doing a play-by-play for like sports. And he plugged in the -3 for the h, and oh, he called his double parentheses. By golly, I don't know any of the old sportcaster lingo, but just trying to have some fun. But that's what it totally feels like the way I'm like talking and doing the presentation.
Professor sounded like Reggie Miller.
Reggie Miller? I don't know anything about Reggie Miller, but I have gotten the two celebrities I've gotten. I don't know if I'll get that recent was Terrence Howard and Chance the Rapper. So, all right, we're gonna have a little bit of fun. I'll be right back. Give me a split second. Let me see if it's still there. You gotta give me like 50 minutes, buddy. Is it gone? It might be gone. I hadn't seen that thing. Oh well. They should have been here. See? Oh well. Okay. Nah, like one year I decided to try to go as like an alternate Chance the Rapper, so I made like a Chance the Rapper hat, but I can't find it. It's somewhere. Anyway, so yeah, what's the time? Okay, we're good. So yeah, we started with the standard form of a quadratic. Now notice again, when we substituted our h, notice we did a blank set of parentheses. So that way we put the -3 inside. The blank parentheses helps us to keep track of the negative, right? So we got a double negative was the positive, okay? And then I think everything else is essentially the same. Also, sometimes the way I talk, because I like practice rapping, I do that whole rapping, that mumble rap syncopation, that whole thing. Sometimes I talk like that. I was like, dang. And I be talking fast. I was like, okay, wait a minute. Anyway, I think we got the same result, right? So that looks good. Let me see what's next. Okay. So I think I want to save this for next time. We have about, I really only want to keep you for about no more than 10 minutes. Class officially lets out at like 4:50, so I'll keep you for no more than 10 minutes. Let's take the next 10 minutes to just kind of keep working. You could, if you wanted to go ahead and start on Pearson. I mean, I guess we could take a few minutes. I like to save. I like to save Pearson for like Fridays and do as much as we can on Friday. But if you wanted to work on Alex or ask questions from any past assignment, ask questions from the exam, you can ask questions on anything you want, really. Yeah, so let's just kind of take 10 minutes and I'll just be available. Let me kind of make my note for next time. So let me see. Usually I'll do Let me see. So we stopped here. What's today? Monday. So yeah, if you are of age to vote, I don't know how, like, because I know you guys are all over, but I know today was the first day for us to vote, so I went on and just knocked it out. If you can vote, it's a good idea. October 12th, 2020. Okay. And then I'm going to say start here. I'm going to say start here, Tuesday, October 13th, 2020. Okay. All right. Yeah. So let me go ahead and make a copy of this available for everybody. And I know someone had a question. I'm probably going to stop the stream, but I know someone had a question at the start of class. We can do a breakout room. Just remind me of who had the. I think it was Mr. Ephraim. But yeah, if you have a question, we can actually do a breakout room and talk about it now. Let me go to paper like this. Okay, I'll be right back, guys. Let me share. I want to send this to box. This is this one. This one. It's this one. This one. Should be 9, right? 9. Okay. Send the box. And then there was something I needed to do here. Okay, we can do Pearson. Let me see. Number 13 from which section? 2.1. Okay. If you're working on 2.1 right now, click on the Ask My Instructor, and yeah, click on the Ask My Instructor, and it'll email it to me. It'll email a screenshot of your very question, and we can pull it up. And just let me know once you've sent it. Once you've clicked on the Ask My Instructor. Okay. Let's see. So I'm not showing anything there, so it should be okay. So let's do like this, not that one. That's showing that. Wait a minute. Let's go here. I think I can open it up here. This isn't connected to anything. This one. It should be this one. Okay, let's pull it up. Okay, that's fine. So I'm just I'm pulling up a copy of it. Let me go ahead and do a blank document. Let's see. For the equation, complete parts A through E. Where's E? Use the graph. Okay. Let me get a copy of this. What's your question on this one, number 13? What's your question with this? It looks like you finished. You just want me to kind of explain it?
Yeah, part D, finding the x-intercepts of that.
Okay. Let me load a copy.
Because I got the answer, but I just don't know how to do the work.
Okay. So then we're going to go here. Let's add photo. This one, right? I think this one. Okay. Oh, are you doing that thing again? Okay. This one. Add. Cool. And then let's blow you up like this. And then let's go paper, graph paper. I'll try to zoom in as best I can. I know it's a little bit small print. I guess what I could do, let's do this. Let's copy and paste. And then here, let's crop this. Kind of like, come on. This might be a little bit better. Okay, let's try this out. Okay. So this says for this equation, complete parts A through E, does the parabola open upward or downward? Okay. So the original, it says is what? Y equals -2 minus 6x minus x squared, right? But if we're talking about a parabola, let's go ahead and put it in the general form. So I'm just going to rearrange it in descending power order, right? So I'm going to do the highest exponent first and then kind of go down from there. So then we're going to say y equals, the highest is going to be -x squared minus 6x minus 2, right? So in this order, now we see that the leading coefficient, namely this guy right here, is negative. So that means the parabola opens downward because, again, our leading coefficient is negative. Right? So the leading coefficient is negative, so it opens downward. Part B asks us to find the vertex. What is this? Okay. So there are a couple of things here. We haven't talked about it yet. For part B, the simple way to find the vertex is use the vertex formula. I think that's coming up, and we can actually transform this into standard form. We have to do completing a square though. I don't want to confuse it with completing a square. Let me just do the vertex formula. I think that'll be the simple way to go for right now, and we'll get some practice with completing the square probably next time. So the vertex formula, if we want the x value of the vertex, which is our h, that's going to be negative b over 2a, right? And let's do this color, right? So if we want the x coordinate of the vertex, again, this is the vertex formula. Is going to be negative b over 2a, right? So if we go back to our, let me take a copy of this one. Copy. It says find the vertex, right? So then we want to find the vertex of this thing. So then from here, we should see that our A is -1, our B is -6, and our C is -2, right? So again, if we want the x coordinate of the vertex, which is our h, again, we're going to do negative b over 2a, okay? So then that's going to be, what's our b? Our b is -6 over 2 times what's our a? Our a is -1. Notice my use of blank parentheses. Every time I went to do a substitution, I use a set of blank parentheses and then plug the number into the blank parentheses. The blank parentheses helps us to keep track of the signs, all right? So now we should see that the double negative becomes positive. 2 times -1 is -2. I think that ultimately is what? Negative 3. It's been a little bit OCD here. I'm going to go like this, move you over here, and then I'm going to put it back. All right, just like that. Boom. Okay. So good enough. So that's the x coordinate of the vertex. So then, now that we have the x coordinate of the vertex, if we want the y coordinate of the vertex, which is going to be the k, we're just going to do f of h. We're going to take that answer and plug it and pass it through the function and see what the output is, right? So in our case, we're going to do f of -3. And let's see, that's going to be, there it is. So that's going to be, we got an x squared minus 6x minus 2. But the x in this case is -3. I'm just going to shrink it down a little bit. It's a little bit. Let's copy. So we're going to plug in our -3 there. We're going to plug in our -3 here. Okay. So then after we crunch the number, so -3 squared is 9 times -1. That's going to, the first one is going to be -9. 6 times 3 is a positive 18 minus 2. So what is that, 7? That's a -11. That's a positive 7, right? So the y coordinate of the vertex is going to be positive 7. Okay? So then that means the vertex should be -3, 7. Okay, that's for part B or whatever. Okay. So then, let me see. Thank you. I see the time. So I think we got that. The axis of symmetry. The axis of symmetry is just going to be the x-coordinate of the vertex. All right, x-coordinate of the vertex. What are the x-intercept or intercepts? Okay, x-intercepts. Okay, so let's start here. So for the x-intercept, right? Let's copy. This is what part D, right? Let's give ourselves some space. D axis to find the x. I see the time, guys. I'm about to let you go. Intercepts. All right. So we want to find the x-intercepts of this. Now, in general, to find the x-intercepts, what we do is set y equal to 0. It's always like the opposites. For the x-intercept, you set y equal to 0. For the y-intercept, we set x equal to 0, right? So if we set y equal to 0, we're going to have to factor, right? Let's do this. So we have this negative x squared minus, and there are a couple of techniques here. We can use a quadratic formula. We can use completing the square. So there's a couple of things. We are expected to be comfortable with factoring at this stage. Now, the typical college algebra student is not comfortable with factoring. If anyone needs help with factoring, just let me know, and we can actually take like a full day. We can kind of start working through some of the factoring techniques. If you remind me, like instead of kind of delaying, we can try to wrap up the lecture tomorrow. We can take like Thursday to kind of get some practice on factoring. But there's a handout that's on our Blackboard page. If you need any kind of help with factoring, just let me know and we can do it. Otherwise, I'll just kind of keep a steady pace. But again, the average student is not comfortable with factoring. I think I'm going to just go ahead and try to squeeze in some factoring here for you guys, because that's the point of our time. So we'll probably, and I know I mentioned that before, and I know I forgot about it. So I'm going to just go back to that. But yeah, at this stage, it is expected that you're comfortable with factoring. We'll take some time to. That's probably what we'll do with any extra time that we have, is to practice our factoring. There was something else I wanted to mention. To solve something like this, and again, we said this is equal to 0, right? We set y equal to 0. We can use the quadratic formula. We're going to talk about that. We can use completing the square. So again, I'll point you in the direction of where we have this whole. I copied this whole chapter devoted to factoring. It doesn't hurt to do a YouTube search on factoring techniques. Like for this one, do a YouTube search on how to complete the square. And people have some pretty nifty, accurate techniques that work that I've never thought of, and they're a lot more simple, right? So let's take some time. I see the clock. I'm going to see if I can just factor this one like normal, right? This is a trinomial. So the first thing I notice is that it has a greatest common factor. So we can divide both sides. We can factor out a -1. So if I divide both sides by -1, then we'll get x squared plus 6x plus 2 equal to 0. Off the bat, I already see. So normally we're looking for two numbers that multiply to give us 2 and add to give us 6. But the only factors of 2 are going to be 1 and 2. So we're not going to be able to factor it like in that sense. So I'm going to use the quadratic formula here. We could use completing the square. I'll save a demo for completing the square next time because we're about out of time. So for the quadratic formula, again, that was coming up. I was avoiding it, but we'll go ahead and do it. It's the following. And I'm going to go ahead and share with you how some of my former Morehouse students kind of how they remember it. I thought it was easy to remember, and they said they told us to maybe once, maybe twice, and it locked in. So this is how some of my students remember the quadratic formula. Again, this is going to be the quadratic formula. Okay, this is another one you would want to add to your formula sheet. It goes like this. So x equals the negative boy couldn't decide to go to the radical house because he was square, so he missed out on 4 awesome chicks, and it was all over by 2 a.m. That's how some of my students. To me, it's like a mini movie, like Hangover. I feel like my references are outdated, like because I know Hangover is not relevant. But that was about the time period where one of the students showed me that. I was like, oh, it's like a mini movie. But that's what it means to get like intimate with the information, right? You just devise little ways of remembering things. So if we use the quadratic formula again, we need to go ahead, and I'm going to use the original items and not my augmented one. But the a from the original was -1. Our b again was -6, and our c was -2. And again, this is just one way. There, you could actually do completing the square. but I'm just trying to choose what I think is the most simple for the time constraints that we have. So then x is going to be negative 6 is going to be 6. I'm going to just kind of jump to the answers a bit. Negative 6 squared is going to be 36 minus 4. Our a is negative 1 and our c is negative 2. Okay. Over 2a, so 2 times negative 1. Okay. If we keep going, 6 plus or minus, triple negative is negative. 4 times 2 is 8. So it's going to be 36 minus 8 over negative 2. If that were minus 10, it would be 26, but that was too much. So it should be 28. So that's going to be 6 plus or minus the square root of 28 over negative 2. 28 is what? 7 times 4? Okay. So this is going to be 6 plus or minus 4 times, you can say the square root of 4 times the square root of 7. We can break it apart like this. Over negative 2. Then the square root of 4 ends up being 2. So that's 6 plus or minus 2 root 7. That's not a 7. 2 root 7 over negative 2. And then we can distribute that negative 2. So that's going to give us a negative 3 plus or minus the square root of 7. Right? And that's where that answer came from. Let me check and see if that's what they have. I see the time. I'm about to let everybody go. I'm not going to take you past 50. Let me check part E. So negative 3 plus or minus the square root of 7. Again, I use a quadratic formula. And then part D asks us to graph. So we can graph the vertex. Where's the vertex? Is negative 3, 7. Let me do a quick demo. Let me try to get a quick demo on graphing. Okay, come on. Say quick. Like this. Let's go here. Shoot. Undo. Like this. Okay. And then like this. Awesome. Okay, this is going to be our positive x in this direction. This is the positive y. I'm watching the clock. I got like 2 minutes. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Let me see. I was doing 3. My vertex was 3 and 7. So let me do like this. It's 3 and 7. Let me just move you down some. Let me copy. Let me go like this. Can I get it? Let's try one more time. Copy, paste. It goes about there. That's good enough. And then let me kind of keep going here. I gotta fix these guys. Okay, that looks good. And then let me go like this. Let me copy. I don't need that many. Let's paste. About right there. And then I'm gonna get rid of this. Okay. So now the vertex we said was negative 3, 7. So 1, 2, 3. I know I didn't put my tick marks. I'm kind of out of time. 1, 2, 3. 1, 2, 3, 4, 5, 6. And 7 is about here. I can't really see it. Let's go like this. Paper. Like this. 1, 2, 3. So that's off. That needs to be about there. All right. So there's the vertex. And then, so now, what we're going to use is the axis of symmetry. We got this guy here. Right? We got this axis. Let's just fix that. We still got a minute. Redo. All right. And then what I'm gonna use this axis style. Let's do it like this. Let's thicken it up. That's about right. Okay. So we can use this axis of symmetry. So whenever we get a point on the left, we get a point on the right as well. It's still a little bit off. Okay, anyway. I see the time. I'm about to let everybody go. Okay. Those are the x-intercepts. So for instance, negative 3. So let's do when x is negative 2. When x is negative 2, right here, that's going to be what? A negative 4. That's going to be a positive 12. So that's going to be a positive 8 minus 2 is 6. So when x is negative 2, y is 6. So that's about here, right? But whenever we get a point on this side, we also get a point over here. I'm coming. I know. Right? And then, you know, you can kind of, let's do another one. When x is -1, I'm going to just do that one quick, and that's going to be it. -1, right? Where is it? That one. -1. That's going to be negative. 6 minus 1 is 5. Minus 2 is 3. So when x is -1, so if we go 2 to the right, we're at 3. 1, 2, 3 is here. But if we go 2 to the left, 1, 2, 3, 4, right here. So whenever we go 2 to the right, we're there. That means also if we go 2 to the left, we have this. And you can kind of continue that pattern all the way down and then connect it. Let me do it like this. Connect it with a smooth curve. Essentially something like that. Come on. There it is. So then let's do like this, like that, and come on. That's about it. That's the gist of it. I had to calculate some other points to get that exact, but you get the idea. That's close enough. Okay. And so on that note, hopefully that answered your question. I know it's a classic. Hopefully that answered our questions, and we're gonna go ahead and wrap up here, guys. Enjoy the rest of your day. We'll be back tomorrow at 3:50. All right. Enjoy the rest of your day. Take care. See you tomorrow.
Thank you, Professor.
My pleasure. Yep. See you. I'm just gonna hold on to that for now. It's time to get set up for the next class. So let me